In this video, I'll be talking about the liquefaction of gases. Let us first see what is meant by liquefaction of gases. So as the term goes, liquefaction of gases. We are going to liquefy a gas, that is a substance in a gaseous state is converted into a liquid state. This process we call it as an liquefaction of gases. So it is the process by which the substances in the gaseous state are converted to the liquid state. How can we achieve this? We all know a gas is a loosely bound one. That means the molecules in the gases are far apart from each other. So first thing we have to do is we have to bring all the molecules together. So how can we bring all the molecules together? For this, we have to apply excess pressure on a gas. So when we apply an excess pressure on a gas, all the molecules come closer together. So the temperature is drastically reduced. So this removes the enough energy from the gas which make them to go from the gaseous state to an liquid state. So apart from applying pressure, the critical temperature and the critical pressure of a gas plays a great role in liquefying the gas. Now comes the different techniques used in liquefying the gases. So these are the different methods employed to produce a very low temperature. The first technique is called method of freezing mixture, evaporation of liquid under reduced pressure, adiabatic expansion of a gas, Joule-Thomson expansion, regenerative cooling, adiabatic demagnetization of a paramagnetic salt. See, out of all these 6 techniques, the adiabatic demagnetization technique is a very useful technique when you need to produce a liquid to a very lowest temperature. Especially this is helpful in liquefying, useful in producing the liquid helium. So next, let us discuss about liquefaction of air by Linde's method. So Linde was the first person to liquefy air. Carl von Linde, as he was called, was a German scientist. He is not only a scientist, he is an engineer and a big businessman. And he liquefied air in 1895 and has also filed a patent rights for this. Now you wanted to liquefy air by his techniques, you have to pay for him. So the principle employed by him is the combination of Joule-Thomson effect and the principle of regenerative cooling. Joule-Thomson effect. So what is Joule-Thomson effect? If a gas which is at a constant high pressure is allowed to move through a porous plug, that porous plug has silk wool or cotton wool, and we all know the silk wool and cotton wool have many number of pores. So when the gas which is at a high pressure is allowed to go through this to a region of constant lower pressure adiabatically, so what happens, already the gases have molecules which are loosely bound. When they go through this porous plug, the molecules are separated furthermore. So this brings down a temperature, brings down a change in the temperature. Either the temperature may fall or the temperature may rise. So it can produce either a cooling effect or a heating effect. So this effect is called as a Joule-Thomson or Joule-Kelvin effect. Next is principle of regenerative cooling. So in this, a small portion of the gas is taken and this gas is allowed to suffer Joule-Thomson expansion. So when it suffers a Joule-Thomson expansion, what happens? The temperature of the gas gets reduced. So this small portion of the gas whose temperature is reduced is used to bring down the temperature of the other remaining portion of the gas, so that the gas keeps on suffering the Joule-Thomson expansion until the gaseous substance is converted into a liquid one. So this continuous process which is used to cool the gas is called regenerative cooling. That means like a positive feedback. A small portion is used to cool the other part of the gas. So Linde used both Joule-Thomson effect as well as the regenerative cooling in his method. So this is the apparatus employed by the Linde for liquefying air. See, in this diagram we can see there are two compressors, pump P1, compressor P1 and compressor P2. Again you have a cold water here which is running, and this beaker has KOH solution. Here you have a freezing mixture, and you could see 3 layers of tube for producing the regenerative cooling, and the valve V1, V2 and V3. Here at valve V1 and at valve V2 the gas will experience Joule-Thomson expansion, and here we have the Deaver flask for collecting the liquefying air. So this is the diagram or the Linde's apparatus. So now let's have a discussion on the processes involved in the Linde's technique. So from the diagram we see there are two pumps P1 and P2. So what happens in the pump P1? So I have mentioned it as in stage 1. The processes that is held in pump P1 is mentioned here as a stage 1. The air which is in the gaseous state is introduced through a valve to the pump P1. So the pump P1 compresses the air to 25 atmosphere, and then it is passed through the next tube which contains cold water where the temperature is further dropped. So the compressed air which is coming out of the cold water, coming out of the tube containing the cold water is passed through the potassium hydroxide solution. The purpose of passing the air to the KOH solution is to remove the impurities and the carbon dioxide and water vapor which is present in the air. From there it goes to the next stage. The next stage in the sense it is going to the compressor number 2. So when it enters the compressor number 2, the pump P2 compresses the air to 200 atmosphere, and then it is fed to a spiral tube which has the freezing mixture where the air is further cooled to minus 200 degrees centigrade. The cooled air is then allowed to throttle through V1 where it suffers the Joule-Thomson effect. You know the Joule-Thomson effect, the air will go from a higher pressure region to a lower pressure region. So during this expansion the pressure is lowered to 20 atmosphere and the temperature of the gas is further dropped to minus 78 degrees centigrade. So the air which is at a normal temperature is now has temperature of minus 78 degrees centigrade. So the cooled air which is flowed through the, now it is passed through the outer tube again to the compressor P2. So what is the function of the compressor P2? It compresses the air to 200 atmospheres. So at this high pressure again the compressed air will enter the freezing mixture, again its temperature will be dropped down there. So after completion of many cycles like this, the temperature of the incoming gas falls sufficiently and the second throttle valve V2 is opened. So once the valve V2 is opened, again it will suffer Joule-Thomson expansion where it is expanded to a very low pressure of 1 atmosphere which results in the liquefaction of air. So the liquefied, once the air is liquefied, the valve V3 is opened and the liquefied air is collected in the Deaver flask. So this process is repeated again and again to collect more liquid air. So the entire arrangement is enclosed in a cotton wool to avoid any conduction or radiation. So these are the chief steps involved in liquefying air by Linde's method. So what is the purpose of liquefying this air? So this liquid air is highly helpful to cool the substances to a very low temperature, and it is used in developing the high vacuum by solidifying the gas which are less volatile than air, and it is mainly used in chemical industries for separation and purification of gases. Apart from this, the constituents of liquid air like oxygen, nitrogen, argon, neon, they can be easily separated and they are widely used commercially. For example, the liquid oxygen is used in metal cutting, like breaking up of old ships, which submerged ships and other machines. It is also used as a breathing apparatus in aeroplanes, mines, and diving suits. The liquid nitrogen is used in the manufacture of ammonia and fertilizers. Liquid argon is used in gas filled electric lamps. Uh, and liquid neon is used in the discharge tubes required for the illumination and advertising signboards. So these are the these are the commercial purposes for which the liquid air is used.